Assalamualaikum class. So in this lecture, we'll be discussing non-discounted methods on evaluating capital investment alternatives. So first, we have payback period. So what is payback period? So payback period is also known as payoff and payout period. So this measures the length of time required to recover the amount of initial investment, and it takes into account liquidity rather than profitability of an investment. So the payback period tells us the length of time that we can recover our investment. So generally, the shorter, the better for lesser risk. So we have our formula. If cash inflows are uniform, payback period would be equal to the net investment divided by annual net cash inflows. However, if the cash inflows are not uniform, so payback period is computed by cumulating the estimated annual cash inflows and determine the point in time at which they equal the investment outlay. So if an additional fraction of a year is needed, the formula would be the net investment less the cumulative annual cash flow divided by the annual cash flow for the current year, where the fraction will be computed. So our decision rule, if our payback period is lesser than or equal to the maximum allowed payback period, then we should accept. If it is greater, then we reject. So for payback period, the shorter the better. So we have here the advantages of payback period. So first, it is easy to compute and understand. Okay, so it is just the net cost of investment, no, and the annual cash inflows. So second, it is used to measure the degree of risk associated with a project. So of course, the longer the payback period, the longer the uncertainty time, the higher the risk. Okay, so that's why for payback period, the shorter the better. And number three, it is used to select projects which provide quick returns of invested funds. Okay, so usually on our investment, we usually ask when would be the payback period, because that would guarantee quick returns of our investments. So for the disadvantages, it does not require recognize the time value of money. Okay, so it is purely no discounting. Okay. Second, it ignores the impact of cash inflows after the payback period, because we usually stop with the computation and the analysis when we compute or when we fully recover the investment or after we get the payback period. Third, it does not distinguish between alternatives having different economic lives. Okay, so um, for payback period, it does not distinguish between shorter or longer time period, because it is just getting the length of time of recoverability, because some projects have smaller cash inflows at the start of the project, at the start of their useful life, but later on they generate large cash inflows along the way. Okay, so some projects have bigger inflows at the start. Okay, so that's why for payback period, it does not distinguish among these different economic lives of project. Fourth, the conventional payback computation fails to consider salvage value. So it does not consider salvage value. It is just looking at the annual cash inflow. So we have the net income. We just add back all the non-cash expenses. And fifth, it does not measure profitability. So only the relative liquidity of the investment. So liquidity, how quick can we um, recover the cash that we invested? Okay, so we have here a sample problem. So we have the following cash inflows for two exploration projects requiring 4 million outright investment. Okay, so we have here for Montgomery and for Diamond. So as you can see for Montgomery, it is uniform cash inflows. For Montgomery, it is just simple, no? We get the payback by dividing the net cost of investment by the annual cash inflows. For Diamond, it is uneven, so we compute every year until we recover the cost of investment. So let's get the payback period. For Montgomery, you can still apply it, no? On the first year, that's recoverable 1 period. Second year, it's 1. So the payback period is 2. Or simply, 4,000 divided by 4 million divided by 2 million. So we get 2. Okay. So our payback period for Montgomery is 2. For Diamond, we still get every year. So since it is uneven, so for the first year, it's 1. Second year, another 1 million, another 1. Third year, it's 1,500,000, so it's another 1. So we need, for the cumulative cash inflows here, we have 1 million plus 1 million, 2 million plus 1,500, we get 3,500,000. So meaning on the fourth year, we only need to recover 500,000. So the formula for the fraction, 500,000 divided by 1,500,000 for cash inflow for that current year. So we get 500,000 divided by 1.5 million, we get 0.33. So for Diamond, our payback period would be 3.33. A self-check question. So this is self-check question number 1. So we have here our second non-discounted method. We have the payback bailout period. So payback bailout period is another variation of payback, but here it considers the salvage value of the project. So bailout period is achieved when the cumulative cash earnings plus the salvage value at the end of a particular year equals the original investment. So if for only a fraction of a year is needed, the formula would be the net investment less the cumulative earnings of last year. So how much is the accumulated earnings last year plus the salvage value of the current year. So the sum of these two would be deducted from our net investment. So we divide that with annual cash inflows. So we have here our problem. Okay, so as you can see here, we have the net cash inflow for the year and the salvage value also for each corresponding year. So we will solve for our payback bailout period. So a project costing 1.8 million is expected to produce this cash flows. Okay, so what is the bailout period for the project? So our cumulative cash flow for year 1, 500,000. For year 2, since 500,000 last year plus 500,000 this year, our cumulative cash flow would be 1 million. So we have a project costing 1.8 million. So meaning for this year, we need to get 800,000. But we have the salvage value here of 500,000. So remember that if only a fraction of the year is needed, we add the salvage value. Okay, so the cumulative earnings last year 1 million plus the salvage value for the current year 500,000. So 1 million plus 500,000, we get 1.5 million for the year 3. So we need here to get 300,000, right? So only 300,000 will be needed here. So 300,000 divided by the current cash inflow for that year, 600,000, and that will give us 0.5. Okay, so as you can see here, payback period 1, 2. So here for the third year, 1 million plus 500,000, so 1.5, so 300,000 divided by 600,000, 0.5. So 1, 2 plus 0.5, so 2.5 years. So this is now time for self-check question number 2. So we have here our third project, non-discounted model. We have the payback reciprocal. So payback reciprocal, so just invert the payback. Okay, so for Montgomery again, we have the payback of 2 years. So the formula again for payback reciprocal is 1 divided by payback period, or the inverse of the payback formula, annual cash inflows divided by net investment. So be reminded that for payback period, this is a reverse, no? Net investment divided by ACI. But for payback reciprocal, this is inverted to get the payback reciprocal. So what is the use of payback reciprocal? So a project with an infinite life would have a discounted rate or return exactly equal to its payback reciprocal. Okay, so second, when a project life is at least twice the payback period and the annual cash flows are approximately equal, the payback reciprocal may be used to estimate the discounted rate of return, or the IRR. Okay, so can get here, our payback reciprocal for Montgomery would be 0.5. That's 1 divided by 2, the payback period, or the other formula, 2 million annual cash inflows divided by cost of investment of 4 million. So we get a 0.5 payback reciprocal. So this may be used to estimate the discounted rate of return, or IRR, of the project. Okay, so we have here we have the accounting rate of return. So for accounting rate of return, our formula would be average annual net income divided by the investment. So take note that among all non-discounted models, only ARR, accounting rate of return, uses the net income figure, because all the rest uses annual cash inflows, right? Okay, so we have here asterisk in the investment because there are two kinds of ARR. ARR based on original investment, and that is the original investment here, or ARR based on the average investment. So we get the average original investment plus salvage value divided by 2. So our decision rule, if accounting rate of return is equal to or greater than our required rate of return, then we accept the project. Okay, so if ARR is lesser than our required rate of return, then we reject. Okay, so the advantages of using ARR, first, it is easily understood by investors acquainted with the financial statements, because May already everyone knows how to get net income, but some are confused as to getting the annual cash inflows. Second, it is used as a rough preliminary screening device of investment proposals, so accept or reject proposals. So the disadvantages of using ARR is, first, again, it ignores the time value of money because it does not discount future cash inflows and outflows. Second, it does not consider the timing component of cash inflows. Third, different averaging techniques may yield inaccurate answers. So, in the averaging, okay, here. And fourth, it utilizes the concepts of capital and income primarily designed for the purpose of FS preparation, which may not be relevant to the evaluation. Okay, cost benefit. So we have here a sample problem. Okay, so there's a piece of labor saving equipment an electronics company could use in one of its plants has the following relevant data. So we have the purchase cost of the equipment, 432,000, annual cost savings that will be provided by the equipment, 90,000, and the life of the equipment, 12 years. What is the simple rate of return to be provided by the equipment? Simple rate of return refers to the ARR based on original investment. So we have here annual cost savings, 90,000. We less the depreciation. So depreciation is 432,000 divided by 12. So we get 36,000. So we have annual income of 54,000. So our formula for ARR is net income divided by cost of investment. So simply divide 54,000 divided by 432,000. So you have simple rate of return of 12.5%. Okay, so let's have an example problem here for average. A company made an investment in video and recording equipment that cost 106,700. The equipment is expected to generate cash inflows of 20,000 per year. How many years will the equipment have to be used to provide the company with a 10% average ARR? Okay, so we have here the average ARR 10%. Okay, so we need to get the useful life of the equipment. So we have here our net investment, 106,000 divided 700. We just divide it by the depreciation expense recognized. Okay, so we have cash flow after taxes of 20,000. Less our net income. How do we get our net income? And that is 106,000 700 times 5%. Okay, so why 5%? Because if the 10% ARR is based on average investment, then divided by 2, 5% ARR will be based on initial investment. So we have 14,665. So our depreciation expense is 5,335. So in average life in years, we have 7.28 years. So we can check that, of course, no? By dividing our net investment, 106,700, okay, divided by 7.28 years, okay? So, 106,700 divided by 7.28, and that would give us 14,650, 665 depreciation. So, may rounding off na discrepancy. Okay, so that is our depreciation, our net income. Okay, so we have again 7.28 years.
Okay, so time for self-check question number 3.
Okay, so let's answer self-check number 4. Okay, so that would be all for this lecture. So next lesson coming up would be capital budgeting lesson 3, discounted cash flow techniques.